Hello, in this lecture we'll find out the area of the circle. In the drawing we have quadrilateral ABCD. Inside this quadrilateral we have this circle. In addition, we know that line segment AB or side AB equals to 2 units in its length. Side BC of the quadrilateral is equal to 8 units. Side DC also equals to 8 units. This angle DCB equals to 90 degrees. This is angle ABC that is also equals to 90 degrees in its size. Our mission is to find out the area of this circle. So first of all, we will do a construction. We'll extend side DA and side CB of the quadrilateral until they touch each other. So this is their touching point. We define the touching point as M. CB is one side of the quadrilateral ABCD, therefore it is absolutely a straight line. We extended the straight line CB by a straight line, and we extended straight line by a straight line. The result must be a straight line. So CM, the result CM is a straight line. So if we focus on the upper side of the straight line CM at point B, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have these angles that is equal to 90 degrees plus angle ABM. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle ABM must be equal to 90 degrees. Again, in order to complete the sum of the angles on the upper side of CM at point B to 180 degrees, the missing angle here must be equal to 180 degrees. Angle ABM must be equal to 90 degrees. Okay? So we define angle AMB as theta, and we will focus on the right triangle ABM. In the right triangle ABM, this angle equals to theta. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, in the big triangle, the big right triangle DMC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we prove that the big right triangle MDC is similar to the small right triangle MAB. Let's repeat again, the big right triangle MDC is similar to the small right triangle AMB. So why those two right angles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle DCM in the big triangle is equal to this angle ABM in the small triangle. Repeat again. Angle DCM in the big triangle equals to angle ABM in the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. It is a common angle that belongs to both triangles, so I can write down that angle theta equals to itself. So angle theta, we can define angle theta as angle DMC. And it equals to itself. Angle theta can be defined also as angle AMB. Repeat again. This equation means that angle theta equals to itself. We just called angle theta two different names. Angle theta, it is a common angle that belongs to both triangles, so angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle MDC in the big triangle is equal to angle MAB in the small triangle. Repeat again. Angle MDC in the big triangle is equal to angle MAB in the small triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually proved that all the three angles in the big triangle MDC are correspondingly equal to all the three angles in the small triangle MAB, A and B. Therefore, the two right triangles are similar to each other according to angle similarity rule. So I write it down. The big triangle MDC is similar. This is the sign of similar to the small triangle A and B. According to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all the triangles in one triangle are correspondingly equal to all the triangles in another triangle, then you actually proved that the two triangles are similar to each other according to angle similarity rule, exactly as we proved on our two triangles. And from the fact that the two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that MC in the big triangle over MB in the small triangle is equal to DC in the big triangle over AB in the small triangle. Repeat again. We derive that MC over MB equals to DC over AB. What is the length of MC? From the domain it is very easy to see that MC equals to MB plus BC. That is to say MC equals to MB plus BC, that is 8. So in total MC equals to MB plus 8. So we substitute MC by MB plus 8 in the equation. MC is MB plus 8 over MB is equals to DC is 8 and AB is 2. So DC over AB, it is 8 over 2, that is 4. 4 equals to MB plus 8 over MB. We will multiply this equation by MB and we will get that MB plus 8 equals to 4MB. We subtract MB from this equation and we get that 8 equals to 4 MB. Also MB is 3 MB. We divide this equation by 3 and we get that finally that MB equals to 8 over 3 units. So here, line segment MB equals to 8 over 3 units in its length. I write it down in the original drawing. This line segment MB equals to 8 over 3 units in its length. In the next step, we will implement the Pythagoras theorem on the right triangle A and B. Here, by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle is AM squared. So AM squared equals to AB squared plus MB squared. Repeat again. In the right triangle A and B, according to the Pythagoras theorem, AM squared equals to AB squared plus MB squared. So AM squared equals to AB squared. AB is 2, so AB squared is 2 squared, that is 4, plus MB squared. MB is 8 over 3, therefore MB squared it is 8 over 3 squared, so AM squared equals to 4, plus 8 over 3 squared equals to 8 squared, that is 64, over 3 squared, that is 9. Here we'll multiply this equation by, we multiply 4 by 9 and then we divide it by 9 in order to have a common factor with 64 over 9, and we get that AM squared equals to 4 times 9, that's 36, so in total in the numerator we will have 36 plus 64 over 9. 36 plus 64, it is 100 over 9. Here we take out of this equation and we get that AM equals to the square root of 100 over 9, the square root of 100 is 10 and the square root of 9 is 3, so in total AM equals to 10 over 3 units. So can I down in the original drawing that AM equals to, the hypotenuse AM equals to 10 over 3 units in its length. In the next step, I present to you rule number 1, and we will implement rule number 1 in our drawing. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Tangent AB is tangent to the circle at point M. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, this means that this angle equals 90 degrees and this angle equals 90 degrees according to rule number 1. We can implement rule number 1 in our drawing. So first of all, we define the center of the circle. This point is O. We join point AB is tangent to the circle at this point, so we define the point of tendency as M. In the next step, we join points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of the circle. We define the radius of the circle as x, therefore OM equals to x. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 1. BC is tangent to this circle at this point. We define the point of tendency as N. In the next step, we join points O and N together by a straight line. ON is the radius of the circle that is equal to X. The radius ON is 1 to point N, that is the point of tendency. Whenever you have a radius that is 1 to the point of tendency, then tangent BC will be perpendicular to the radius NO. If BC is perpendicular to NO, it means that this angle equals to 90 degrees. This angle equals to 90 degrees according to rule number 1. So in quadrangle MOBN, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the missing angle. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. Okay. 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles in any quadrangle. In the next step, we will draw perpendicular on BC in such a way that it will be also tangent to the circle. So first of all, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular and BC as H. We define the point of tendency of the perpendicular with the circle as K. We'll extend the perpendicular HK until it touches side MD of the triangle. And we define the touching point of the perpendicular and extended HK and side MD as T. So actually, tangent TH is tangent to the circle at point K. We will join points O and K together by a straight line. OK is the radius of the circle that is equal to X. The radius OK is 1 to point K, that is the point of tendency, or tangent TH of the circle. And whenever we have a radius that is 1 to the point of tendency, then tangent TH, this tangent TH will be perpendicular to the radius KO. If TH is perpendicular to KO, then this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 1. In quadrangle ONHK, we have 1, 2, 3 right angles, therefore the fourth angle must be equal to 90 degrees according to the rule that I already mentioned, that the sum of the angles in any quadrangle is equal to 360 degrees. So angle MOK, this angle equals to 90 degrees plus 90 degrees, it is 180 degrees. Again, angle MOK equals to 180 degrees in its size. Any angle that is equal to 180 degrees must be a straight line. MOK, therefore it is a straight line. If MOK is a straight line, then MK is also a straight line. The straight line MK touches the circle at points M and K. Therefore, the straight line MK is a chord. So chord MK passes the circle, passes from point O, that is the center of the circle. Again, chord MK passes through point O, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle, therefore MK is the diameter of the circle. Okay, so I can write down that chord MK is the diameter of the circle. In the next step, we'll focus on quadrilateral MBHK. Again, quadrilateral MBHK. Inside quadrilateral MBHK, we have 1, 2, 3, 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we will relate to quadrilateral KMBH as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, MK equals to BH in rectangle KMBH. Again, MK equals to BH. So you can write here that MK equals to BH. And from this equation, BH equals to MK equals to the diameter, we will derive that BH is also the diameter of the circle. But we also know that the diameter of any circle is twice as long as the radius, and the radius is x, therefore the diameter BH must be equal to 2x. BH equals to 2x. Here, the diameter BH equals to 2x units in its length. In the next step, we will focus on the right big triangle MTH. On the right big triangle MTH, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. So already explained before. In the next step, we will prove that the big right triangle MTH is similar to the small right triangle MAB. Because again, the big triangle MTH is similar to the small right triangle MAB. So, why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So we can write down that angle THM in the big triangle is equal to angle ABM in the small triangle. This angle repeat again. Angle THM in the big triangle is equal to angle ABM in the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, those two angles are both, this angle theta, is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself. Angle theta, you can define angle theta as angle TMH. And you can also define angle theta as angle AMB. Repeat again. this equation means that angle theta equals to itself. We just call to angle theta two different terms. Angle theta is a common angle that belongs to both triangles. So angle theta equals to itself. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So you can write down that angle MTH in the big triangle is equal to angle MAB in the small triangle. Repeat again. Angle MTH in the big triangle equals to angle MAB in the small triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the three angles in the big triangle THM are correspondingly equal to all the three angles in the small triangle A and B. Therefore, the two right triangles are similar to each other according to angle similarity rule. So I write it down. The big triangle THM is similar to the small triangle A and B, according to angle similarity rule. And for the fact that the two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that MH in the big triangle over MB the small triangle is equal to TH in the big triangle over KH over AB in the small triangle. Repeat again, we derive that MH over MB equals to TH over AB. From the drawing, it is very easy to see that MH equals to MB plus BH. So MH equals to MB, that is 8 over 3 plus BH, that is 2x. In total, MH equals to 8 over 3 plus 2x. Over MB, that is 8 over 3, and it is equal to TH. TH is unknown, so we leave it as it is. TH over AB. AB is 2, so we substitute AB by 2. We found out that 8 over 3 plus 2x over 8 over 3 equals to TH over 2. Here we multiply 2x by 3 and then we divide it by 3 in order to have a common factor with 8 over 3, and we get that in the numerator we have here 8 plus 2x times 3 is 6x over 3 over 8 over 3, that is equal to TH over 2. So here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. So in this part of the equation we left only with 8 plus 6x over 8, that is equals to TH over 2. Here we cross multiply this equation and we get that 2 times 8 plus 6x equals to 8 times TH. Repeat again, 2 times 8 plus 6x is equals to 8 TH. we divide this equation by 2, and we'll get that 8 plus 6x equals to 8 over 2 is 4, so in total this expression equals to 40h. Here we'll divide this equation by 4, and finally we get that th, the length of line segment th, is actually equals to 8 over 2 is 8 over 4. 8 over 4 is 2, plus 6x over 4 is 1.5x. So in total, the length of line segment th equals to 2 plus 1.5x. So we can write down here that the length of this line segment th is equal to 2 plus 1.5x. Because of the fact that the big right triangle TMH is similar to the small right triangle MHB, AMB, we derive that addition relationship exists between their sides. We derive that MH in the big triangle over MB, the small triangle, is equal to TM in the big triangle over AM in the small triangle. Repeat again, we derive that MH over MB equals to TM over AM. We already found out that, I already explained to you that MH is 8 over 3 plus 2x over MB is 8 over 3 and it is equal to Tm. From the drawing it is very easy to see that Tm equals to Ta plus Am. That is to say Tm equals to Ta plus Am, that is 10 over 3. Okay, so Tm equals to Ta plus 10 over 3 over AM is 10 over 3. So 8 over 3 plus 2x over 8 over 3 plus 2ta plus 10 over 3 over 10 over 3. Here we multiply 2x by 3 and then we divide it by 3, and then here also we multiply ta by 3 and we divide it by 3. So here in the numerator we have 8 plus 2x times 3 is 6x over 3 over 8 over 3. That is equals to 3ta, 3 times ta is 3ta plus 10 over 3 over 10 over 3. So we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. We have also here 3 in the numerator and 3 in the denominator, so 3 will get cancelled. So in this side of the equation we left only 8 plus 6x over 8. That is equals to 3ta plus 10 over 10. Here we cross multiply this equation and we get that 8 times 10 times 8 plus 6x equals to 8 times 3ta plus 10. We'll open the brackets on both sides of the equation. And you get that 10 times 8 is 80, plus 10 times 6x is 60x. That is equals to 8 times 3ta is 24ta, plus 8 times 10 is 80. So here we have 80 on both sides of the equation. So 80 will get cancelled. and we left only with 60x, that is equals to 24 TA. So here we will divide this equation by 24, and finally we get that TA, the length of line segment TA, it is equals to 60x over 24, it is equals to 2.5x. So the length of this line segment TA is equal to 2.5x. In the next step, I will copy quadrangle ATB edge in the new page here. So actually this is quadrangle ATB edge that I copied from the original drawing. This quadrangle ATB edge blocks this circle, so I'll copy the circle in the new drawing here. The circle and the quadrangle touch each other at 4 points. 1, 2, 3, 4. 3, 4. That is to say, the circle and the quadrangle have 4 points of tangencies between them. We define the first point of tangency as M, the second point of tangency between the quadrangle and the circle as N, the third point of tangency as N, and the fourth point of tangency between the circle and the quadrangle is K. In the next step, I will present to you rule number 2 and we implement rule number 2 in our drawing. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. We have the common external point P. From the common external point P, we have two tangents to this circle, tangent TA and tangent TB. And according to rule number 2, the lengths of those two tangents are equal to each other. That is to say, PA equals to PB. So, according to rule number 2, whenever you draw two tangents to a circle from a common external point, then their lengths must be equal to each other. In this case, PA equals to PB. We can actually implement rule number 2 in our drawing. We focus on the common external point A. From the common external point A, we have two tangents to the circle, tangent AM and tangent AN. And according to number 2, they are equal to each other. That is to say, AM equals to AN. EM equals to AN. So if we define the length of the tangent AM as A, then the length of tangent AN must be also equal to A. We focus on the common external point, point B. This point B. From the common external point, point B, we have two tangents to this circle, tangent BN and tangent BL, and according to rule number 2, they are equal to each other. That is to say, BN equals to BL. So if we define the length of tangent BN as B, then the length of tangent BL must be also equal to B because they are equal to each other. The next step we focus on the common external point, point H. For the common external point, point H, we have two tangents in this circle, tangent edge L and tangent edge K, and according to rule number 2, they are equal to each other. That is to say, edge L equals to edge K. So if we define the length of tangent AL as C, then the length of tangent AK, edge K, must be also equal to C. And finally, we focus on the common external point, point T. For the common external point, point T, we have two tangents to this circle, tangent TM and tangent TK, and according to rule number 2, they are equal to each other. That is to say, TM equals to TK. So if we define the length of tangent TM as D, then the length of tangent TK must be also equal to D. So in the next step, we will add side AT to the opposite side, side BH, in quadrangle AT-BH. AT plus BH. What is the length of side AT? From the drawings, it's very easy to see that AT equals to A plus D. So I substitute AT by A plus D in the equation here. A plus D plus BH. What is the length of BH? BH equals to B plus C. So I substitute BH by B plus C. So in conclusion, we found out that AT plus BH equals to A plus D plus B plus C. We can change the order of the letters here. Instead of A plus D plus B plus C, you can write down A plus B plus C plus D. Those two expressions are equal to each other. We just change the orders of the letters. Okay. In the next step, we will add side AB to the opposite side, TH. AB plus TH. What is the length of AB? From the drawing, it is very easy to see that AB equals to A plus B plus TH. What is the length of TH? Here TH. It is very easy to see that TH equals to C plus D. C plus D. So in total, AT side AT plus side TH equals to A plus B plus c plus d exactly is the value of the expression of at plus bh. It is also equals to a plus b plus c plus d. And because of the fact that those two expressions, they are both equal to the same expression a plus b plus c plus d, it means that they are equal to each other. So you can write down that at plus bh, it is equals to ab plus th. Okay, those two expressions are equal to each other. At, here, we already found out that at equals to 2.5x, so we substitute at by 2.5x in the equation, plus bh. We already found out that the length of line segment BH, it is equals to 2x. Therefore, we substitute BH in the equation by 2x. And it is equals to AB. AB is 2, so we substitute AB by 2 plus TH. Here, TH is equals to 2 plus 1.5x, so we substitute TH in the equation by 2 plus 1.5x. So in total, we found out that 2.5x plus 2x equals to 2 plus 2 plus 1.5x. 2.5x plus 2x is 4.5x. So 4.5x equals to 2 plus 2, that is 4, plus 1.5x. Here we subtract 1.5x from this equation, and we get that 4.5x plus 1.5x, it is 3x. So 3x equals to 4. We divide this equation by 3, and finally we get that x equals to 4 over 3 units. So the radius of this circle x is equal to 4 over 3 units. Our mission is to find out the area of the circle. We actually know that the area of any circle here, the squared brackets is the sign for the area. The area of any circle is equals to pi times the radius squared. If r is the radius, then it is pi r squared. Now a specific circle, the radius of the circle is defined as x, therefore it is pi x squared. The area of our circle is pi x squared. We just right now found out that x equals to 4 over 3, so you can substitute x here by 4 over 3, so it is pi times x is 4 over 3. If x is, so x equals to 4 over 3, therefore x squared must be equal to 4 over 3 squared. So the area of the circle equals to pi times 4 over 3 squared. 4 over 3 squared equals to 4 squared, that is 16, over 3 squared, that is 9. So in total, we found out that the area of this circle, it is equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. And that is the answer to our question. In the next step, I'll summarize the lecture. So In the drawing we have quadrilateral ABCD. Inside this quadrilateral we have this circle. We know that side AB equals to 2 units in length, side BC equals to 8 units, and side DC also equals to 8 units. This angle DCB equals to 90 degrees, and this is angle ABC that is also equals to 90 degrees in its size. Our mission is to find out the area of this circle. In order to find out the area of the circle, we did a construction. We extended side DA of the quadrilateral and side CB by straight line until they touch each other. Again, we extended side DA and side CB until they touch each other. Actually, they touch each other at this point. We define the touching point as M. So here, CB or BC is one side of quadrilateral ABCD, therefore it is absolutely a straight line. When we extended the straight line CB by a straight line, the result is CM. When you extend the straight line by a straight line, the result must be a straight line, therefore CM is a straight line. If you focus on the upper side of the straight line CM at point B, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is equal to 90 degrees plus the missing angle ABM. In total they must be equal to 180 degrees according to the rule that I mentioned. So 90 degrees plus angle ABM must be equal to 180 degrees. Therefore the missing angle ABM must be equal to 90 degrees. In order to complete the sum of the angles on the upper side of CM at point B to 180 degrees, the missing angle here ABM must be equal to 90 degrees. So in the right triangle ABM, we define this angle as theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta, it is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. Then we focused on the right big triangle MDC. In this right big triangle MDC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta, exactly as we did in this triangle ABM. So the missing angle here must be equal to 90 degrees minus theta. Then we proved that the big triangle, the big right triangle MDC is similar to the small right triangle ABM. Why those two triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, it is a common angle that belongs to both triangles, so angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we proved that all the triangles in the right big triangle DCM are correspondingly equal to all the triangles in the right triangle ABM, therefore we proved that those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that MC in the big triangle over MB in the small triangle, is equals to DC in the big triangle over AB in the small triangle. I repeat again. MC over MB equals to DC over AB. From the drawing, it is very easy to see that MC equals to MB plus BC. That is to say, MC equals to MB plus BC, that is 8. So in total, MC equals to MB plus 8. So we substitute MC in this equation by MB plus 8. So it is MB plus 8 over MB over DC is 8, AB is 2. 8 over 2 is 4. So MB plus 8 over MB equals to 4. We multiply this equation by MB and found out that 4 times MB equals to MB plus 8. We subtracted MB from this equation and found out that 8 equals to 4MB minus MB, it is 3MB. So 8 equals to 3MB. We divided this equation by 3 and found out that MB equals to 8 over 3 units. Here, this line segment line segment A and B equals to 8 over 3 units in its length. Then we implemented the Pythagoras theorem on the right triangle A and B. According to the Pythagoras theorem in the right triangle A and B, AM squared equals to MB squared plus BM squared. Repeat again. In the right triangle A and B, AM squared equals to AB squared plus MB squared. So AM squared equals to AB squared. AB is 2, so AB squared is 2 squared, that is 4, plus MB squared. AB is 8 over 3, therefore MB squared is 8 over 3 squared. So AM squared equals to 4, plus 8 over 3 squared equals to 8 squared, that is 64, over 3 squared, that is 9. Then we multiplied 4 by 9, and then we divided by 9, in order to have a common factor with 64 over 9. 4 times 9 is 36, so in total, in the numerator we have 36 plus 64 over 9. 36 plus 64, it is 100 over 9. We took out all of this equation and finally found out that AM equals to the square root of 100 over 9. The square root of 100 is 10 and the square root of 9 is 3. So in total AM equals to 10 over 3. The total AM equals to 10 over 3 units in its length. Then I presented to you rule number 1 and we implemented rule number 1 in our drawing. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. We have tangent AB that is tangent to this circle at point M. The radius OM is drawn to point M, that is the point of tendency, and whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. According to this rule number 1, we implemented rule number 1 in our drawing. So first of all, we define the center of this circle as O. We define the point of tangency of tangent AB with this circle as M. We join points O and M together by a straight line. Point O is the center of the circle. Point M is the point of the circle itself. Therefore, OM is the radius of the circle that we define as X. So the radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. Whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius OM. If AB is perpendicular to OM, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. We define the point of tendency of tangent BH with this circle is N. We join points O and N together by a straight line. ON is the radius of the circle that is equal to X. The radius ON is drawn to point N, that is the point of tendency or tangent BH with this circle. And whenever you have a radius that is drawn to the point of tendency, tangent BH will be perpendicular to the radius NO. If BH is perpendicular to NO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So in quadrilateral OMBH, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the missing angle. In total, it must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. Then we draw perpendicular on BC in such a way that it will be also tangent to the circle, point K. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We extended the perpendicular HK until it touches side DM at point T. So we have tangent TH is tangent to this circle at point K. We join points K and O together by a straight line. OK is the radius of the circle that is equal to X. The radius OK is drawn to point K, that is the point of tendency of tangent TH with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent TH will be perpendicular to the radius KO. If TH is perpendicular to KO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So in quadrilateral OK, edge, and we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees according to the rule that I already mentioned, that the sum of the angles in any quadrilateral is equal to 360 degrees. So angle MOT, this is MOK. This is angle MOK. It is equal to 90 degrees plus 90 degrees. It is equal to 180 degrees. Repeat again, angle MOK equals to 180 degrees. Any angle that is equal to 180 degrees must be a straight line. Therefore, MOK is a straight line. If MOK is a straight line, then it means that MK is also a straight line. So the straight line MK touches the circle at points M and K, therefore MK is a chord. Angle line segment MK is a chord. Okay? MK touches the circle, line segment MK touches the straight line MK touches the circle at points M and K, therefore the straight line MK is a chord. And the chord MK passes for point O, that is the center of the circle. Any chord that passes for the center of the circle must be the diameter of the circle, therefore MK is the diameter of the circle. So I can write down here that MK is the diameter of the circle. Then we focused on quadrilateral MKHB. This quadrilateral, inside this quadrilateral, we have 1, 2, 3, 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral MKBH as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle MKBH, side MK must be equal to the opposite side BH. So MK equals to BH. You can write down that MK equals to BH, and from this equation BH equals to MK equals to the diameter, we will derive that BH is also the diameter of the circle. And you know that the diameter of any circle is twice as long as the radius, and the radius of this circle equals to x according to our definition. Therefore, the diameter must be equal to 2x. BH is the diameter of the circle, that is equal to 2x. So you can write here that this line segment BH equals to 2x. Then we focused on triangle, the right triangle and the right big triangle MTH. In the right triangle MTH, this angle equals to 90 degrees, this angle equals to theta, therefore the missing angle must be equal to 90 degrees minus theta, as I already explained before. Then we proved that the big right triangle THM is similar to the small right triangle ABM. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, it is a common angle that belongs to both triangles, so angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we proved that all the three angles in the big right triangle THM are correspondingly equal to all the three angles in the small right triangle ABM, therefore those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that M edge in the big triangle over MB in the small triangle equals to AB, M edge in the big triangle over MB in the small triangle equals to T edge in the big triangle over AB in the small triangle. I repeat again. M edge over MB equals to T edge over AB. So here, it is very easy to see from the drawing that M edge equals to MB plus B edge, that is to say M edge equals to MB, that is 8 over 3 plus B edge, that is 2x. So in total, M edge equals to 8 over 3 plus 2x, so we substitute M edge here by 8 over 3 plus 2x. MB equals to 8 over 3, so substitute MB by 8 over 3, and it is equal to T edge is unknown, so we leave it as it is. AB is 2. Then we multiply 2x by 3 and then we divide it by 3. In order to overcome factor, we put over 3. So in the numerator we will have here 8 plus 2x times 3 is 6x, 8 plus, so in total in the numerator we have 8 plus 6x over 3 over 8 over 3, that is equals to 2 th over 2. So we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled, and we left only in this side with 8 plus 6x over 8. That is equal to th over 2. Here we cross multiply this equation, and we found out that 8th equals to 2 times 8 plus 6x. So I repeat again. After we cross multiply the equation, so we cross multiply the equation and found out that 2 times 8 plus 6x equals to 8th. We divided this equation by 2 and found out that 8 plus 6x equals to 8 over 2 is 4. So in total this expression equals to 4th. Then we divided this equation by 4 and found out that the length of line segment th equals to 8 over 4 is 2 and plus 6x over 4 is 1.5x. So in total the length of line segment th equals to 2 plus 1.5x. th equals to 2 plus 1.5x. Then, because of the fact that the big right triangle THM is similar to the small right triangle ABM, we can conclude that addition relationship exists between their sides. The following relationship exists between their sides: that MH in the big triangle over MB in the small triangle, it is equal to TM in the big triangle over AM in the small triangle. I repeat again. MH over MB equals to TM over AM. I've already explained to you that MH equals to 8 over 3 plus 2x, MB is 8 over 3, and it is equals to TM. TM from the drawings is very easy to see that TM equals to TA plus AM. That is to say, TM equals to TA plus AM, that is 8 over 3, so in total TM equals to TA plus 10 over 3. So we substitute Tm here by Ta plus 10 over 3. Over Am is 10 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to overcome factor of 8 over 3. And here also we multiply Ta by 3 and then we divide it by 3 in order to overcome factor of 10 over 3. So here in the numerator we have 8 plus 2x times 3 is 6x over 3 over 10 over 8 over 3. Again, 8 plus 6x over 3 over 8 over 3. This is equals to 3 times Ta is 3Ta plus 10 over 3 over 10 over 3. Here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. Also here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. So here we left only with 8 plus 6x over 8 is equal to 3Ta plus 10 over 10. We cross multiply this equation and found out that 10 times 8 plus 6x is equals to 8 3Ta plus 10. We opened the brackets on both sides of the equation and found out that 10 times 8 is 80 plus 8 times 6x is 60x. That is equals to 8 times 3 is 8 times 3Ta is 24Ta plus 8 times 10 is 80. So we have 80 on both sides of the equation, so 80 will get cancelled. And finally we found out that 60x equals to 24Ta. We divided this equation by 24 and finally we found out that Ta equals to 60x over 24 equals to 2.5x. So the length of line segment TA equals to 2.5x. So we can write here that TA this line segment TA equals to 2.5x units in stack. Then I copy it for the other ATHB here in the new page. This is for the other ATB edge that I copied from the original drawing. This quadrangle blocks this circle, so I copied the circle in the new drawing. The circle and the quadrangle touch each other at 4 points. 1, 2, 3, 4. Actually, there are 4 points of tangencies between them. Points M, K, L, and N. Then I presented to you rule number 2, and we implemented rule number 2 in our drawing. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. We have the common external point P. From the common external point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule number 2, they must be equal to each other. That is to say, PA equals to PB. So whenever you draw two tangents to a circle from a common external point, then the lengths of two tangents must be equal to each other. In this case, PA equals to PB. You can implement rule number 2 in our drawing. Why? Because in our drawing we have the common external point A. From the common external point A, we have two tangents to this circle, tangent AM and tangent AN. According to rule number 2, they are equal to each other. That is to say, AM equals to AN. So if we define the length of tangent AM as A, then AN must be also equal to A. Then we focus on common external point B. From the common external point B, we have two tangents to this circle, tangent BN and tangent BL. And according to rule number 2, they must be equal to each other. That is to say, BN equals to BL. So if we define the length of BN as B, then the length of tangent BN must be also equal to B. Then we focus on the common external point H. From the common external point H, we have two tangents to this circle, tangent HL and tangent HK. And according to rule number 2, they are equal to each other. That is to say, HL equals to HK. So if the length of line segment HL is C, then the length of tangent AHK must be also equal to C. Then we focus finally on the common external point T. From the common external point T, we have two tangents to the circle, tangent TM and tangent TK. And according to rule number 2, they must be equal to each other. That is to say, TM equals to TK. So if we define the length of tangent TM as D, then the length of tangent TK must be also equal to D. Then we added side AT to the opposite side BH in quadrangle ATBH. So AT plus BH. AT is A plus D and BH is B plus C. So in total, AT plus BH equals to A plus D plus B plus C. We can change the order of the letters here. Instead of A plus D plus B plus C, you can write down A plus B plus C plus D. Those two expressions are equal to each other. We just change the order of the letters. Then we added side AB to the opposite side, TH. So it is AB plus TH. AB is A plus B and TH is C plus D. So in total, AB plus TH, it also equals to A plus B plus C plus D, exactly as the expression AT plus BH, it is also equals to A plus B plus C plus D. So those two expressions, they are both equal to A plus B plus C plus D, therefore they must be equal to each other. So you can write down that this expression AT plus BH equals to this expression AB plus TH. Okay, AT plus BH equals to AB plus BH. So here, AT, the length of AT is 2.5x, so we substitute AT by 2.5x plus BH. BH equals to 2x, therefore we substitute BH in the equation by 2x. And it is equals to AB. AB is 2, therefore we substitute AB by 2x by 2 in the equation, plus TH. TH equals to 2 plus 1.5x, therefore we substitute th by 2 plus 1.5x in the equation, and finally found out that 2.5x plus 2x equals to 2 plus 1.5x. 2.5x plus 2x is 4.5x, and it is equal to 2 plus 2, that is 4, plus 1.5x. We subtracted 1.5x from this equation and finally found out that 4.5x minus 1.5x, it is 3x, that is equal to 4. Then we divided this equation by 3 and finally found out that x equals to 4 over 3 units. That is to say, the radius of this circle x, it is equal to 4 over 3 units. So our mission is to find out the area of this circle. The square brackets here is the sign for the area. It means the area of the circle, of any circle, it is equal to pi times the radius squared. If r is the radius, then it is pi r squared. In our specific circle, we define the radius as x, therefore the area of the circle will be equal to pi x squared. We have already found out that x equals to 4 over 3, so we can substitute x by 4 over 3. We did it and found out that pi x squared is pi times 4 over 3 squared. So it is pi times 4 over 3 squared. Pi times 4 over 3 squared is 4 squared, that is 16, over 3 squared, that is 9. So in total we found out that the area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, the area of this circle equals to 5.585 square units. So repeat again, the area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. Okay, thank you very much.